All right, welcome back. Today, we are going on a quest, a big one. We're on the hunt for the largest single objects in the entire universe, black holes. Let's get right into it.
Okay, so to even start this search, you gotta wrap your head around one absolutely wild idea. See, unlike a star or a planet, which can only get so big before it collapses or just falls apart, a black hole doesn't really have that problem. You can just keep feeding it, and it'll just keep on growing and growing and growing, theoretically, forever.
So that leads to the big question, right? If they can just grow without a limit, what's the current record holder? We're about to go on a journey of cosmic scale, starting with the small fry and working our way up to the undisputed heavyweight champions of the universe.
Here's our roadmap. We'll start with what are called stellar-class black holes. Then we're going to take a supermassive leap to the giants that live in the center of galaxies. From there, we'll meet the ultramassive kings, and then we'll finish up with a really crucial reality check on how we even know any of this stuff.
All right, first up, stellar-class black holes. I like to call them the cosmic bullies. And, well, you're about to see exactly why.
So what are these things? Basically, they're born from the fiery death of a really massive star. When the star dies, its core just collapses in on itself. And to talk about how heavy they are, we use a pretty simple unit of measurement, a solar mass. One solar mass is just the mass of our sun. It's a great little yardstick for the insane weights we're about to deal with. Now check out this incredible cosmic mismatch. On the one side, you have this huge red giant star, 30 million kilometers across, and its dance partner, a tiny black hole, no bigger than a city. But, and this is the crazy part, that little dot is so unbelievably dense, so massive, it literally throws the giant star around in their orbit. It's the perfect example of how mass, not size, is what really counts. So just how big can these stellar bullies get? Well, they can grow by crashing into each other. When two black holes merge, they create a bigger one. And in the process, they blast out more energy in gravitational waves than all the stars in our galaxy combined do over thousands of years. We actually detected one of these mergers, and the result was a brand new black hole clocking in at 142 solar masses. But this is where things get weird. It's a real mystery. See, astronomers find plenty of black holes up to around 150 times the mass of the sun. And then, poof, nothing. A massive, empty gap in the records until you suddenly start finding black holes that are millions of times bigger. Why is there a gap? Honestly, it's a puzzle we're still trying to figure out. So let's just leap right over that strange gap and go to the next level. And trust me, it's not a step, it is a giant leap. We are now in the realm of supermassive black holes, the absolute kings of our universe. And guess what? We've got one right here in our own galactic backyard. Meet Sagittarius A star, the monster lurking at the heart of the Milky Way. Its mass, a mind-boggling 4 million times the mass of our sun. Suddenly, that 142 solar mass black hole seems kind of cute, doesn't it? Now, here's a really important point, a common mistake people make. It's so easy to imagine this giant cosmic anchor holding our whole galaxy together, right? Kind of like the sun holds the planets in orbit. But nope, that's not how it works. A supermassive black hole is usually a tiny fraction of its galaxy's mass. We're talking 0.001%. The real glue, the invisible scaffolding holding billions of stars together, is something we can't even see. Dark matter. As we look farther out into the universe, the scales just become absurd. Take the black hole in the galaxy Cygnus A. If you were to drop that thing where our sun is, its edge, not its center, its edge, would stretch out past the orbit of Neptune, almost halfway to the very edge of our solar system. It would just swallow every single planet. Gone. And here it is, an icon. The very first black hole we ever managed to take a picture of. What you're seeing here is the shadow of M87's black hole, cast against all the glowing hot gas swirling around it. This beast has a mass of 6.5 billion suns, and it's so big it wouldn't just swallow our planets, it would swallow our entire solar system, the whole shebang. But And you're not going to believe this. We can still go bigger. There's a class even above supermassive. So let's go meet the ultra-massive kings, the largest single objects we think can even exist in the universe. The physics at this scale is just beautifully strange. Out in the galaxy OJ-287, there is an ultra-massive black hole that weighs in at 18 billion solar masses. And what's orbiting it? Not a star. Oh no. It's another supermassive black hole, one that is itself 40 times bigger than Sagittarius A star in our own galaxy. A black hole orbiting an even bigger black hole. Just let that sink in for a second. And that brings us to the big one. The undisputed heavyweight champion of the universe, the most massive black hole we've ever found. Its name is TON 618. And its mass? It's a number that almost doesn't mean anything. 66 billion times the mass of our sun. Let's try to make sense of that, okay? Imagine you could take a trip inside. You cross its event horizon. That's the point of no return. You're now traveling at the speed of light, headed for the center. That journey would take you a full week. A week, traveling at the fastest speed possible, just to get to the middle.
So forget swallowing our solar system. That is child's play for this thing. To really put its size into perspective, you could line up 11 of our solar systems from end to end, and they would all fit comfortably inside of TON 618. It is, for all intents and purposes, the biggest single object we know of.
Okay. Wow. But before we all just float away on these completely insane numbers, let's ground ourselves for a second. Let's do a quick reality check. Because how on earth do we even know any of this?
This is really important to remember. We don't see black holes directly. We can't. We just see what they do. We figure out their mass by watching how their immense gravity makes nearby stars wobble. And as you can imagine, those calculations come with some pretty big uncertainties. We also have to simplify things by assuming the black holes are perfect, non-spinning spheres, which, of course, they aren't.
You know, the team that put together the source material for this explainer put it perfectly. This quote just captures how difficult this science actually is. It's a constant debate, a process of scientists basically driving each other crazy to agree on the best possible numbers they can live with. It really shows you the incredible dedication that goes into all this. And that leaves us with one last truly mind-bending idea to chew on. See, because TON 618 is so incredibly far away, the light we're seeing from it is ancient. We're looking at a photograph that's 10 billion years old, which means for the last 10 billion years, it's just been sitting there, feeding and growing. So the real question isn't how big it was, it's how much bigger is it right now.